Welcome to the explainer. So think about the very last application you built. You know, the one you poured hours into, crafting that absolute perfect logic? Well, I have a terrifying reality for you. That app you just built, it isn't really yours. Today we're focusing on how to take back control of your software supply chain before it's too late.
Now, don't panic just yet. In this explainer, we have a clear roadmap to arm you with the exact defensive strategies you need. We're going to cover the third-party threat, transitive dependencies, and supply chain attack vectors before equipping you with your defensive arsenal, language-specific tools, and finally, a solid developer's checklist.
Section 1. The third-party threat, the code you didn't write.
Okay, let's dive into this unseen danger lurking right beneath the surface of your application. When you build a modern app today, about 70 to 90% of it is actually just frameworks, libraries, and toolkits pulled straight from public registries. You wrote maybe 15% of it. The rest? It's literally someone else's code. But here's the catch. You are now completely responsible for securing it.
To put the sheer scale of this into perspective, the average JavaScript application pulls in over 1,000 dependencies. 1,000! And here's exactly why this matters to you. When a vulnerability hits just one obscure package, your whole application is exposed, your user data is at risk, and you are the one getting that dreaded caffeine-fueled 3 a.m. wake-up call.
The industry is definitely recognizing this massive danger. OWASP categorizes this exact threat as A06, vulnerable and outdated components. And guess what? It moved up from number 9 in 2017 all the way to number 6 in 2021. The problem is getting worse, not better. Running unsupported software with known common vulnerabilities and exploits, or CVEs, is a massive blind spot, usually because teams just don't know what dependencies they actually have running in their stack.
Section 2. Transitive dependencies and Log4 shell, the iceberg beneath.
To understand exactly why these hidden dependencies are so incredibly dangerous, we have to revisit the nightmare scenario of December 2021, 10.0. That is the highest, most terrifying CVSS or vulnerability scoring system rating possible. This was Log4 shell. It was a zero-click remote code execution nightmare inside a Java logging library called Log4j, and it was sitting in millions of applications globally. Patching it actually took months for many organizations. Why? Not because the code fix was hard, but because just finding where Log4j lived in their ecosystem was nearly impossible.
And that's because Log4j was usually a transitive dependency, a dependency of your dependency. It's like a giant iceberg. The direct dependencies you purposefully installed, those are just the tip. But beneath the surface, that dependency tree goes 4 to 5 levels deep. You never explicitly chose this code, but your application runs it anyway. That means you inherit every single vulnerability hiding in that massive block of ice.
Section 3. Supply chain attack vectors beyond the CVE.
We really have to shift our mindset here, because accidental bugs aren't your only enemies. Attackers are actively and intentionally infiltrating the supply chain. Imagine an attacker setting a trap. They might use typo squatting, publishing a malicious package named requets instead of the wildly popular requests library, just waiting for your fast fingers to make a typo during install. Or they use dependency confusion, publishing a malicious package on a public registry using the exact same name as your company's private internal package. Or perhaps most chillingly of all, they compromise the account of a trusted maintainer and push a malicious update to a totally legitimate package. Your best defense? Review new dependencies with intense skepticism. Look, if a package has 3 downloads and was published last week, definitely do not trust it.
Section 4. Your defensive arsenal, taking back control. So now that we see the true scale of this threat, let's empower you with the exact concepts and tools you need to lock down your environment. Meet your new best friend, Software Composition Analysis, or SCA. SCA tools automatically scan your project's dependency manifest and your log files, cross-referencing every single package and version against major databases like the National Vulnerability Database, the NVD, to find known flaws. This is an absolutely essential defense, because let's be real, no human being can track a 1,000-package dependency tree manually. You need this scanning happening on every single commit.
Another core defense is strict lock files. You see, a loose version range allows patch and minor updates to flow in automatically. If a bad actor compromises the next minor version, your build just happily pulls it in. Lock files prevent this entirely by pinning exact versions for reproducible builds. These aren't just generated files you should ignore, they are vital security artifacts that absolutely must be committed to your version control.
Of course, pinning versions means you have to actively manage your updates. And let's be honest, manual updates simply don't scale. You need an automated strategy. First, automate your monitoring with tools like Dependabot. Second, prioritize those security patches above all else. Third, absolutely require your automated tests to pass before any update merges into your code. And finally, always have a fast rollback plan ready to go just in case an update breaks something in production.
Section 5. Language-specific security tools. The right gear.
And this brilliantly illustrates exactly which tools you need based on your specific tech stack. If you're writing Python, you'll want pip audit or safety for native scanning, paired with pip tools and Dependabot. Over in the JavaScript ecosystem, NPM Audit and Yarn Audit are your primary built-in scanners, with Snyk and Dependabot handling the advanced CI side. And for Java developers, the OWASP Dependency Check plugin is standard, combined with Maven Enforcer and Snyk. But here is the absolute golden rule across all of these. Your CI pipeline must act as an unforgiving gate. If these tools detect high-severity vulnerabilities, they need to fail the build immediately.
Section 6. The Developer's Checklist. Securing your build.
Let's summarize all of this into actionable rules you can integrate right into your daily workflow. Remember, you own the security of every single line of code your application runs, and that includes all third-party code. To protect it, run those SCA tools in your CI pipeline on every single commit. Commit and protect your strict lock files. Automate your dependency updates, because honestly, doing it manually is completely unsustainable. And review all new dependencies with deep skepticism.
All right, it is rapid-fire quiz time to cement what we've learned. First question. What OWASP Top 10 category covers vulnerable and outdated components? Think back to the trend we discussed. Yep, it's A06. And remember, this threat is actively rising in priority because the problem is just getting worse out there.
Next up, what is a transitive dependency and why does it matter for security? Picture the iceberg. It's a dependency of your dependency, code you didn't explicitly choose but your application runs it anyway. You inherit all of its vulnerabilities, which is exactly how Log4Shell caused so much global damage.
Let's conclude with this final test. Can you name 2 tools for automated dependency vulnerability scanning? If you said Snyk, Dependabot, OWASP Dependency Check, or native tools like NPM Audit, you hit the nail on the head. You now have the knowledge you need to secure your software supply chain. But I'm going to leave you with this final thought. Knowing just how deep that dependency iceberg really goes, is your next deployment truly secure?